Hello and welcome to UiPath Advanced Training, User Interface Interaction. In the previous training, you learned about the basics of recording UI interactions and parameterizing them to suit your needs. Today, we'll take it a step further by looking at the various input and output methods, the technology behind them, and when to use each one. You'll also learn about a new technique, web scraping, a method of extracting tabular or otherwise structured data out of web pages. Being an advanced training, it'll be a bit heavier on the theoretical side, but don't worry, you'll get to experiment with the different new concepts and see them in action. That being said, onwards! By now you should be familiar with basic recording. All UI interactions in UiPath fall in one of the two categories, input and output. Input actions are the ones where you, or in this case the robot, take some direct actions on the application or web page that you're automating. Things like clicking, typing, keyboard shortcuts, and so on. They make the application do something. Output actions are those actions that get information out of the app and into UiPath for further processing. They're not recordable because all apps are made for humans, whose main output method is reading the results on a display. UiPath has various methods for simulating all the actions that a human can make, and more, and we'll look at them in detail. There are three main input methods available for click and type actions: default, simulate, and window messages. Their capabilities and compatibility vary, so you're free to test and choose the right one for your specific requirements. The default method uses the mouse and keyboard drivers to simulate a human operating them. It's the method that works every time, but with a few downsides, like speed and the requirement to have the application active. So it's a good idea to start with this method to make sure that everything works, and then change it to one of the other two methods. Fortunately, it's as easy as clicking a checkbox in the Properties pane of Input Actions. The other two methods have different capabilities and requirements, so make sure you try them both when developing a workflow. Our recommendation is, if you don't need to send special keyboard shortcuts, try the Simulate method first, because it's the fastest of the three, and it also works in the background. Then try the Window Messages method. Let's try a quick test. We'll make a workflow that types a text in Notepad and then minimizes the window and then types some more, because we want to see how background operations work with each method. We'll start with a basic recording. Start recording, click the editable area and type something. Then we'll minimize the window, since we want to test the background capabilities of different input methods. Now we'll restore it because we want to enter more text and type something. In our case, this works in background too. And escape to pause and escape again to save. Inside the recorded sequence are the four actions you took. To test the background operations, we'll make an important change. We'll take the action that restores the minimized Notepad window and move it after the type into action. This way, the type action happens while Notepad is minimized. We'll also add a line break before the type text to test keystroke capabilities. Normally now would be a good time to start experimenting with the different input methods that we described earlier by choosing each one at a time down here and seeing how they work with your workflow. For a better view of how they perform, let's look at all three methods side by side and analyze the differences. On the left is the default method, the one we just made. The other two are identical workflows, the only difference being the input method used for the type into action. And these are their settings in the workflow. Let's start them all at the same time and see what happens. That was pretty fast, but we can see the results are a bit different. The default method gives the expected result, but wasn't very fast. The window messages approach is very similar, but apparently converts all text to lowercase. It's also the slowest. So if speed and uppercase characters are needed in your workflow, you'd better look elsewhere. The third method, Simulate Type, was the fastest, but the results are not quite as expected. First of all, even though the empty field box was unchecked, the second text completely replaced the first one. That's a current limitation of this method that can be solved by adding a getText before the type into method and appending your text to it, but more on that later. Another difference from the other two is this text here, the keyboard shortcut appearing in our text. Simulate Type cannot send keyboard shortcuts, so if that's important in your workflow, you should use one of the other two. Let's look at the slow motion replay of the running workflows to see more differences. The first one to finish entering the line of text is the Simulate method, and the first to minimize the window. The other two are slower, almost equally so. By the time the default minimizes the window, Simulate has finished entering the text whilst the window was minimized and restored Notepad from the taskbar. When default comes back up, it's because it doesn't work in the background. It needs focus to be able to work, exactly as a human would, and it's the second one to finish, closely followed by the Send Window Messages method that type the text whilst minimized. Feel free to watch this slow-mo replay a few more times if you'd like to take a closer look at how they behave, but the moral of the story is that there are differences between the methods and you should always try them out and choose the best one for your use case. Next up, output methods. Now, in the previous training, the one about recording, you encountered the get text action. We used it to get the results from an expense application and calculate the price drop for a specific financial stock. That was the simplest output action and it worked great. However, this is an advanced training for those situations when you need more than simply getting a tiny piece of data. You may want to get bigger blocks of data, or you may want to get information behind complex UIs that's difficult to get, or you may need to find an exact word position, color, or other granular information about some text. For those situations, UiPath has an innovative screen scraping tool that allows you to easily find the best output method for your project. These are the 3 screen scraping methods that can be used to extract data out of applications, browsers, documents, and even virtual machines, images, and others. Even more than their input counterparts, they are different in their strengths, weaknesses, and intended use. Full text is the default method, and it's the best one for most situations. It's fast, accurate, and it works in the background. The native method has the advantage of being able to extract word information, like the screen coordinates of each word or character. We'll see how that can be useful in a minute. And the last one, OCR, as you may know, in general OCR technology is not 100% accurate, but it does work as a last resort in situations where none of the other direct methods give us the intended results. Let's see some practical examples. You can access the screen scraping tool here in the main toolbar, but for the rest of this training, we'll access it from the smaller Quick Access toolbar. When started, the screen scraping tool acts just like the basic screen recorder. You point it at the information that you want to extract. We have a few apps opened here for testing purposes. Notepad, the Internet Explorer browser, and 2 demo apps that use slightly different rendering technologies. Let's say you need to scrape this whole address section in My CRM application. Click on an area that highlights the section you need. The screen scraping wizard appears, giving you choices for the scraping method and other configuration options. These are the alternative scraping methods, and here is the method that was chosen by UiPath as the best one for the indicated element. This is the preview area, and it shows you the scraped information in its raw form. We can see that out of that whole section, only the editable fields were scraped. If we try the full text method, the results are quite different. Full text retrieves the visible text, the editable boxes, and some hidden information too. We can choose to ignore the hidden information by checking this option and rescrape to see what we've got. So, even without hidden information, in this case, the full text method gives us significantly more information than the native method. OCR is a whole different beast. It looks at the indicated area as an image, and it tries to read it. This method tends to pick up some errors, so it's suitable for situations where complete accuracy is not paramount. There are 2 available OCR engines, each pre-installed with dictionaries for different languages to aid in the word recognition process. The MS Office OCR is suitable for larger images, like scanned documents, receipts, and so on, and Google's engine works better with smaller, low-resolution images, like interface elements and such. And it has a few more options specific for these purposes. An invert option for white-on-black images, because black-on-white text recognition works better, and scale, an option to upsample images for better results. It's a good idea to try these options and interactively see the results in the preview pane and find the best combination for your specific use. We'll come back to these and more options for screen scraping, but for now, let's click Continue to see what we get. Inside the attached window, there's a Get OCR text action. The selector identifies the element to scrape, and the output text variable contains the scraped text. Let's add a write line after the scrape to print the results. As you can see, the results from this OCR method are not quite perfect. One option is to try the Microsoft Office OCR by dragging it inside the Get OCR action. We'll also increase the scale to 3 because this engine works better with larger images. These results look a bit better, but if you'd like, you can also change the container OCR method to one of the other output methods by dragging them from the Actions panel, just like any other action. There are 4 main UI output methods and their corresponding actions. Let's drag all of them into our workflow to see how they compare. And indicate the same area to scrape. Or you can copy the selector to the other actions, it's the same thing. Let's also set up 3 more variables to print the results. We'll name them getText, getFullText, and getVisibleText. And we'll rename this one to getOCR. And we'll choose to ignore the hidden text for full text. Then we'll set up the variables in each action. And let's print them all one after the other. We'll use this bigger editor because it's more convenient for longer strings. And add a new line after each one by adding a plus environment new line. And this is how the outputs for all 4 actions look like. Let's quickly run through a few more screen scraping examples to explore its behavior and some more options. We'll start with this expense report application. The full text method scrapes pretty much all the information in the window and no hidden information is found. The native method doesn't work at all on this app, and OCR gives decent results but with a few minor errors. Let's try scraping a different app by going to this very useful Scrape Another Element button up here. We'll try it on this notepad window. If we change the method from OCR to native, we get a very clean scrape. The full text method also works great with a slightly different formatting. Now let's try it on a browser window. We'll indicate this black region over here. The full text and native methods are unable to extract any information out of it, so it's OCR's time to shine. It looks like the Microsoft OCR engine worked flawlessly out of the box, with no mistakes whatsoever. Google's OCR is a complete mess, because the indicated region contains white text on black background. We can easily fix it by choosing to invert the source image and rescrape to see the results. Perfect. No mistakes from this engine either. Now you should have a better understanding of how screen scraping helps you extract relevant information out of any source. Now that brings us to the last output technique that I want to show, web scraping. Web scraping is different from all the other methods we've used before because it's designed to extract a special kind of data, structured data, and all the other methods can extract free-form data. Structured data is a type of information that follows a certain pattern. Think of the search results on any website. That is structured data. The information made up of blocks with an identical formula. They each have a title, a URL, and a description. Or in Amazon's case, the formula is a bit more complex, but it's still the same for each block. A title, a cover, a date, the name of the author, the price, rating, and many others. UiPath has a very helpful wizard for extracting such structured data into a usable form, a data table or spreadsheet. It works through a very simple process. You point at the first element in a data block, then the same element in the second block. UiPath then highlights and extracts the other elements that correspond to the pattern that it identified. There are a few more details to the whole process, so let's look at a practical example. Let's say you want to extract the results from an Amazon search with title, author, and price, and save it to an Excel file. When you start the web scraping wizard, you're first asked to indicate the element that you want to extract. Hit Next and click the title of the first book. Then you have to click on the second element. So Next and indicate the title of the second book. Since the title of the book is also a link, UiPath asks which of the two you need. We'll choose both, and we'll name each data with an appropriate name. Title and URL. When you hit Next, you'll see a preview of the scraped area in the form of a spreadsheet. UiPath also highlights the scraped data on the page so that you can easily verify everything works as expected. We could click Finish at this time if this was all the information that we needed to extract, but we also want the author and the price for each one. So we'll click on Extract Correlated Data and follow a similar process. Indicate the first two occurrences of the data we want to extract. So, Next, first author, Next, second author. And the same as before, we can extract the links to the author's page if we want, but this time we'll just get the name and click Next. We can see that the appropriately named column has been added to our spreadsheet, and let's repeat the process to get the price for each book. When you click Finish, you have the option to point to one last element, the next page link, for cases where the results span multiple pages. In our case, we'll scroll to the bottom of the page, click Yes, and then indicate the next page link. And that's it. Our workflow is ready to extract information from all the pages of that Amazon web search. But before we hit play, let's save all this information into a CSV file that we can use in other applications or workflow. We'll add a write CSV action right after the web scrape. In the first field, we'll put the name of the new file, and in the second one, we'll put the output variable from the web scraping action. And now it's ready to run. We can see it go through all the pages and extract the information that we need. Now let's have a look at the CSV file. There are 4 columns, one for every type of data that we scraped, with convenient column names at the top. The file has 100 entries, but that's not a coincidence. It's the result of a setting from the extra structured data action called max number of results. I guess that's pretty self-explanatory, so feel free to modify it to suit your needs. In a future tutorial, you'll learn more about data tables, so you can process the extracted information however you want, not just save it to a file. And that's pretty much it. But before we go, I want to show you one last trick of the web scraping tool, and that is the fact that it can scrape HTML tables with one click. No need to teach it the pattern. For example, if we scrape any web page containing a table, like this Google Finance page that we used before, it can automatically extract the whole table by rows and columns and on multiple pages. Here it is, asking us if we want to extract the whole table. If we choose no, we continue the extraction the same way we did before by pointing at the first and second items in the list and adding correlated data if we need it. So let's click yes for the easier option. We're greeted with a preview of the scrape data table. Let's limit the scrape to the last week by setting the maximum results to 7. Click finish and no for multiple pages since we don't need it this time. And inside the web scraping sequence, we'll add a write CSV action after the extract action to see the results. We'll get the output from the extract action and use it for the input data table, and we'll save it as Google stock last 7 days.csv. Now let's see what we got. And this is our scraped data. In a future tutorial, you'll learn more about data tables, so you can process the extracted information however you want, not just save it to a file. This concludes our advanced UI interaction training. Let's see a quick recap of what you've learned to make sure that everything is settled in. Today, we took a closer look at the different input and output methods in UiPath. 3 input methods and 3 output methods, each with its own strengths and weaknesses. We compared all of them and noticed that some are faster than others, some work in the background, and some are more compatible with third-party apps than others. So you should get to know all of them because they're all useful in their own way. Then we learned about a special output technique, web scraping, a process used for extracting tables and other correlated data out of web pages. Input and output interactions are at the core of UiPath, so make sure you're comfortable with most concepts and activities covered in this video, as you will use them extensively. Till next time, take care.